Assalamualaikum and good day everyone. Our group is Group 4 is going to do a DIY spectrophotometer. Here is our group members. These are all the apparatus and materials we have used. We use black box, rose syrup, cuvettes, and dropper. We use green backlight and tune to approximate 500 nanometer light, and this is the link. We made 2 holes at the front and also at the back of the box. Also, we made the opening on top of the box. We have prepared 1 blank and 5 sample solutions by adding different concentrations of rose syrup to the solvent, which is the tap water, in separate cuvettes. The blank solution is in cuvette 1, while 3 drops of syrup is added for the cuvette 2, 6 drops syrup in cuvette 3, 9 drops syrup in cuvette 4, 12 drops syrup in cuvette 5, and 15 drops of syrup in cuvette 6. To operate the DIY spectrophotometer, the cuvettes were placed in the right place. A blank was measured for the background correction for the accurate analysis. The RGB values was measured by using Carolina apps. Then, the cuvette 2 was placed into the DIY spectrophotometer to measure the absorbance using the desired wavelength of light. Next, the above steps were repeated with cuvette 3, 4, 5, and 6.
This is the results of our DIY spectrophotometer we did. It shows that there is a drop, concentration rate value, or we say RGB value, intensity, and absorbance. Alright, from here we calculate intensity by using RGB value. For example, we take a blank one, which is 0 drop. We have RGB value of the same value, which is 255. First, we sum up all of the RGB value and divide it by 3 because it has 3, and it will be 255. And it will go on as the other drop or the other samples. And we calculate our absorbance by using the formula of A is equals to log I naught over I. As we know, I naught is the original or the blank intensity. For example, we can see here is 0 drop, which is I naught is 255, and I is the others below it. Then we take a look at the graph from our table. This is the graph of absorbance against concentration. As we can see, absorbance is directly proportional to the concentration. It is in a linear line, and we can see it is almost at a 0 point. The equation we got from this graph is y is equals to 3.4788x plus 0.0934, and the r square value is 0.902.
Our DIY spectrophotometer offers several notable advantages. Firstly, it is designed to be user-friendly and efficient, allowing a smooth workflow when taking measurements. The data collected by the Carolina at RGB calorimeter can be synchronized and displayed on an external screen, which improves convenience and reduces handling errors during analysis. In addition, this DIY spectrophotometer is cost-effective. It is constructed using inexpensive and easily available materials, making it an economical alternative to commercial spectrophotometers while still fulfilling basic analytical requirements. Another major advantage is the reduction of light scattering. The cuvette is fully enclosed within the device, preventing interference from external light. As a result, light only passes through the sample and directly reaches the sensor, leading to more accurate and reliable readings. Despite its advantages, this DIY spectrophotometer has several limitations. Inconsistent cuvette positioning is a major concern. Since the cuvette holder is manually aligned, slight variations in placement can lead to irreproducible and inaccurate measurements, affecting result reliability. Another limitation arises from the use of the Carolina RGB meter application. The accuracy of the readings depends heavily on the smartphone's camera quality, sensor sensitivity, and also the positioning of the smartphone. To add, the system is susceptible to handling errors. Oils or residues from the user's hand may be transferred onto the cuvette surface, which can alter light transmission and distort absorbance readings. Finally, due to these limitations, the DIY spectrophotometer is not suitable for high precision or professional analytical work. It serves best as an educational and experimental tool rather than a replacement for commercial-grade spectrophotometers.